is the speed of light actually constant, as Einstein said? Well, there is now a veritable mountain of experimental support behind the idea that the speed of light is constant. I'm not going to review all the evidence, but let me just give you two examples that I think give a nice sense of the way physicists go about checking that kind of an assertion. So the first experiment, as I'll show you in a moment, involves two particles coming together, and sometimes when particles collide, they produce a flash of light, a photon. Now, if the particles are quickly moving, they should be able to give the light a kick if the speed of light were not constant. So what physicists have done is they have looked at the speed of light coming off particles that are slamming together. Here they are. They come together. You would have thought, boom, that the particles' motion would have imparted an additional speed to the speed of light, making it go faster than 300 million meters per second that we have over here. But the data shows that the speed of the light coming off the colliding particles is unchanged. It is constant. It is not affected by the speed of the colliding particles. That's one kind of experiment. Another kind of experiment is a fun one, which is to look at orbiting binary stars and consider the light that they emit. So if you imagine we have a situation like this, where here we are on Earth, and far away there is a star orbiting another star. And here's the thing. Let's imagine incorrectly that the speed of light could be affected by the speed of the source. So for instance, when the star is at the top of its orbit, it would give the light an additional push. When it's at the bottom of the orbit, it would restrain the speed of the light, making it go more slowly. So let's put in the incorrect notion that the speed of the light can be affected. So imagine then at the top of the orbit, the light that's emitted versus the light that was emitted over here at the bottom of the orbit. If the speed of light behaved as we would expect based on experience and the laws of Newton, we would think that the speed of light, c, so we'll always use the symbol c for the speed of light, c plus v, if this guy has a speed v going in that direction. Incorrectly, let's assume that you can increase the speed of the light. In this side, of course, the star was over here, and it's moving in that direction at that moment with the speed v. So you'd think, based upon baseballs and hand grenades, that the speed of the light coming off the star would be less, c minus v. If that were the case, notice that something weird could happen. It could be the case that the light emitted by the star over here, since it's traveling more slowly toward Earth, might arrive at Earth later than the light that was emitted later on when the star is in that position. Or the light emitted here and here, this guy's getting a head start being emitted sooner, but he's traveling slower. Maybe they'll reach Earth at the same moment. What then would that mean for observations? We might see the star jump from one point in the sky to another based upon the particular particle of light, the particular photon that's reaching us at any given moment. So let me show you then what might happen if this were true. It's not, but the observations are what allow us to conclude that. So let's look at a case where we see now the light that's coming off the star, and you'll notice that light emitted at the bottom loses the battle to light emitted at the top if it were the case that the speed of the light coming off the orbiting star was affected by the motion of the star itself, giving it a kick or pulling it back. And the fact that when we look at these orbiting stars, we never see the star jumping from one point in the sky to the other. We never see this weird effect of light coming from one position having a different speed than light coming from another position in the orbit. Another piece of strong experimental evidence that the speed of light is constant. Now this is a fun little example that is good to play with, and oftentimes in the discussion I'm going to provide you with demonstrations that allow you to feel the results in, I don't know, a more visceral way than just hearing somebody tell you about them. So here is an example where you are able to study this idea that if it were the case that the speed of light were not constant, then you would receive light from the star's orbit in a variety of strange sequences. So this is demonstrating a wrong idea, but I'm having you do it because this is evidence for the speed of light being constant by the fact that we don't see the results that you are able to play with here. So how does this work? You can choose the distance of the binary star system from the Earth. You can choose the angular speed. And then when you hit play, the star will go around, and you'll see that if it were the case that the speed of the light were affected by the motion of the orbiting star, let me just show you that again, we would find, for instance, light emitted earlier would arrive later. And you can crank the angular speed of the orbiting star up even further, make the effect more dramatic. And there you see, look how slow that light is traveling if it were the case that its speed was affected by the speed of the source. And the fact that we never see that happen is strong evidence that the speed of light cannot be changed by the speed of the source. The speed of light is constant. And to tell you the truth, perhaps the most convincing evidence behind the constancy of the speed of light are indirect tests that have been carried out over the course of many years, which test the implications of the constant speed of light, the implications that we are going to spend a lot of effort developing. But the bottom line is, there is now universal acceptance that the speed of light is constant, and then it is up to us to use our understanding of what that means for physics to figure out the implications for the nature of reality. That is where we are headed.